Hello again. Today we are going to do the experiment on the optics, and it is the experiment 8. And on Blackboard, you're going to go to the module 8 and go click on this experiment 8 optics. And you will see again a simulation link and the handout and the exercise or the assignment document. So you click on this link, and that will give you this simulation link right here. And I want you to download this, and I want you to download this. I already downloaded them and I kept them ready. So I have one of this handout is right here. So I want you to read this handout so that you can understand the theory behind what we are doing. So what is a reflection, what is refraction, and all those is given right here. I'm just going to show you how to do the experiment. Okay, so for that I'm just going to move on to this procedure section right here, and I'm going to go to this link which is given right here. So I always encourage you to do it as two windows side right next to each other, so that you can just read this and do the experiment. Okay, so now I know that this is the simulation I need to click on, so I just clicked on that, and then I have this simulation right here. It's loading. So now I'm just going to go to the intros of the thing. So now you can see that it is exactly looking like what I have it on the thing on your handout. So in here I'm just going to have this material as air, and the other material as the water right here. And then I'm just going to move on to the second step. As you can see on your right hand side of the window, measure one is air and the other one is water, so just keep them as is. And under the toolbox right here, you have right here, this is the toolbox right here, you have a protractor which will give you the angles from 90 to 0, 0 to 90, and so on and so forth. So and move the protractor right here, and I want you to start your experiment by pressing this laser right here. So now I'm just going to turn this laser light on right here. So when you shining this light, this is the laser light right here. So what's happening is this laser is traveling in the medium air right here. So you can see that what you have right here, this white medium is air. So it is traveling in a straight line. You can see that straight, that's path is straight. Once it hit the other medium, which is the water, some of the light is reflecting. So it just hit this other surface and it reflected, and some of the light is passing through the water. So we want to, that's why we want to find out what is the law of reflection and refraction. Okay, so I'm just going to, in order for us to make our readings a little bit easier for us to understand, so I just want you to move this to 30 degrees so that you can see what angle it is, what angle of incidence. So the the light, it is falling at an angle that is called the incident, angle of incident, and the one which is reflecting at whatever the angle it is, this is called angle of reflection, and this angle is called the angle of refraction. Okay, so now you can see that the angle is 30 degrees. So I want you to go to the table. So right here, angle of incident is 30 degrees, and then I want you to look at this right here as the angle of incident as 30 degrees too. Okay, so right now I don't want you to worry about the refraction because I'm going to show that in the next table. So here I'm just going to show you the reflection. Okay, so now I'm changing it to 60 degrees. So what happens if I change my incident ray at an angle of 60 degrees? Then let's see what happens to this reflection. See, when you change it to 60 degrees, now the reflection or angle of reflection also changed to 60 degrees. So this is what we were talking about, that angle of incidence is always equivalent to angle of reflection. This is called the law of reflection. Okay, so I want you to change more angles, and I want you to play with it a little bit and see how the angles are, and I want you to fill this table right here. Okay, Now moving on to the second part. Which is now I'm going to look at the refraction part. Okay, so because I'm done with this reflection, I'm just going to leave it as is, and then I'm going to check what's happening to my angle of refraction. Okay, so I'm just going to move it right here, 30 degrees right here. So see, now you have the reflection angle is 30 degrees right here. So you're going to put it as the angle of incidence is 30 degrees right here. Now you look at the angle right here. So now it is not quite 30 degrees yet. So it is 24. So now you can see that, like, the path, it kind of changed. It kind of, like, moved a little bit when it went through the water. The same ray, when it passes through the water, it just changes its angle. So now when I'm moving to 60 degrees, my angle is 40. Okay, so this is 40 degrees. Okay, so I want you to keep changing the angle, and I want you to note down the angles. So now I just want you to, so this is done. I want you to continue to do that, and based on the observations, I want you to answer these questions, like what is law of reflection, what is refraction, what's happening in the experiment. You're going to answer those, and you're going to answer these questions based on the theory. You have it right there, and based on this formula right here, you're going to enter these values, and you're going to make it average, and you're going to have an average right here and plug in those numbers right here, and then you're going to find out the speed of the light in water. Now I just want you to explore a little bit of things right here. So if the material was something else, let's say glass, so what happens to the ray when it is passing through? So if I'm sending it 60, so what's happening to right here? So angle of incidence and angle of reflection, it is being same, but only thing is that when it is passing through the glass versus when it is passing through the water, the angle of refraction is changing. Okay, so I just want you to observe, play with a little bit of material. So if water to water, so let's say that if water was up and down both, what happens to the laser? See, now you can see that the water can pass through this, so the ray can pass through this water without any issue, just like no matter how far it is, it's going to pass in the straight line path. Okay, so I just wanted you to, so now let's say that if it is going from water to air, what happens? See this. See, if it is going from water to air, all the lighting is going to reflect back. It's not going to pass through the light. So that's the reason, like when you see the light under the water, if you do it, it's not going to go, you would not be able to see it on top of the surface of the water, like in oceans or whatever. So in that context, so I want you to explore a little bit and see how the fascinating these results you can explore from here. Okay, so this concludes I want you to finish this report, and again it has the assignment sheet too, but which has exactly same table, so you can submit only one report as a report for this experiment. Okay, I hope you understood the optics, and you have a few more simulations in the PHY where you can explore more on concave lenses and convex lenses, how the size or the image of anything will change based on if you are using a concave lens or convex lens, and what distance and things like that you can explore for having a little bit more knowledge on optics. Okay, bye.